The goal of the LISA project is to detect gravitational waves from space. So LISA will observe gravitational waves at lower frequencies than one can possibly detect on the surface of the Earth. LISA stands for the Laser Interferometer Space Antenna. LISA and gravitational wave detection in general is an entirely new way to observe the universe. So the LISA observatory consists of 3 satellites that are orbiting the Sun, and they roughly form a triangle. In each spacecraft there are test masses, which are blocks of gold platinum that are freely floating inside the spacecraft. And the 3 spacecraft are separated by 2.5 million kilometers. And we use a laser to measure very precisely the separation between these test masses in the 3 spacecraft. As a gravitational wave passes through this constellation of spacecraft, the apparent distance between the test masses oscillates back and forth. And by observing this, we can learn about the source of the gravitational wave. So the piece of technology that we are developing for LISA involves charge buildup on the test masses. So since these test masses are freely floating inside the spacecraft, they are free to build up a static charge, just like people experience here on Earth. And now we need to control that charge without applying any forces to the test mass that could look like gravitational waves. And the way we do that is using ultraviolet light. The process of our research is iterative. First, we come up with a basic design on paper and pencil or computer models, and then we will develop what's called a breadboard. So design and fabricate the basic elements and features of the technology and just show that it works in a laboratory setting. Then over the course of several years, we will redesign, we'll learn about what we designed and tested before. We'll design a higher fidelity version of the hardware and continue to test it in an environment that's more flight-like, so vacuum environment, the appropriate temperature environment, and so on, until we get to the point where we have hardware that looks essentially like the hardware that we're going to fly in space. We have a mission goal of 4 years of lifetime on orbit, but we are designing the observatory so that it should last up to 10 years.